Hey, art nerds, we are going to be talking about the element of color, and you might be a little surprised at some of the things that you'll be finding out by the end of this video. So, for starters, I want you to quick check out this video. I have the link in the description below, and watch that first, and then jump back into this video. So, what we have for color, and it's going to be kind of surprising, but color is produced when light striking an object is reflected back into your eye. Okay. So in that little diagram on the left-hand side, we have the sun, our light source, and the light from it is hitting the vehicle, the red car. And because of the wavelength of light that is being reflected by that car is, red, that's how we perceive that the car is actually red. Okay, so the weird thing to kind of wrap your head around is that the car isn't red, it reflects red light. So if that's a little bit confusing, you might want to watch this video. This will help so much in trying to wrap your head around the fact that, the t-shirt that you're wearing right now actually isn't that color. It reflects that wavelength of light, which is why when it is dark in the room, why your shirt looks darker, or if it's really bright outside, your shirt looks brighter. So that is something that you will be learn a little bit more about by watching this video. So watch this and jump back in here. So now that you kind of understand how color kind of works, you saw this visible spectrum in that video and how all light is in waves. Okay, so we have the ones that we can't see, like I can't see radio waves, but they're there. Okay, and then we also have X-rays, gamma rays, infrared, microwaves, all those things. And there's a tiny section that's our ultraviolets. That's the visible spectrum. Okay, and if you take a look at the waves, you have big slow waves for like red, but as you move across, the waves get tighter and tighter and tighter and closer together. So they're moving more quickly, okay? There's more peaks within the same distance. And this is also kind of why if you take a look at like a rainbow after it rains, why red is always on the outside, traveling the furthest distance, and then purple or indigo is more like on the inside. Okay, so you have those different wavelengths, and that's why you'll never see a rainbow out of order or missing a color for that matter, because it has the entire visible spectrum in that arch and that's coming because it's reflecting through the water molecules that are in the air. Super cool. And then in the wintertime, you got sundogs reflecting off of the ice crystals in the air, which is also really cool. So check it out if you've never seen that before. Google it. Anyways, so we have this really compressed these waves that you're actually able to see versus all the ones that exist, which is really crazy to wrap your head around. And understanding how light works and how color works is actually super cool. Science is super cool. Anyways, color in art can actually do a lot of things. First of all, it expresses emotion. So it could give an emotion like happy or have hope, or it could make you think of, sadness or sorrow, tragedy. And we also have color that can attract attention. So it makes your eyes look at something in a work of art. So maybe it's that big red cape around Napoleon being like, look at me, I'm Napoleon, I'm super awesome, check out my horse. Okay. And then we also have the same kind of thing here, but with the big white dress and then the red framing around the woman's face, making us look at her because everything else is kind of a little bit darker and she's very light and bright. Okay, and then we also have color telling you where a boundary is. So it lets you know where the background stops and the figure of the woman with the pearl earring begins. And it also lets you know, where hair stops and where the background starts. Because in the first image, you couldn't see where Marilyn's hair stopped. But now with the yellow, we know where the hair stops. Okay, we have a clear boundary defined using color. So, question for you. What are primary colors? Not what are they, but what are the three primary colors? I want to know what they are. How would you describe them? Okay. We like to describe primary colors as any group of colors from which all other colors can be obtained by mixing. And believe it or not, there's actually more than one set of primary colors, and we'll be talking about that in a short bit. So we have this work of art by Roy Lichtenstein. He was a pop artist. This is actually a work of art that is more inspired from like a comic strip, okay? And his work is very graphic, just like a comic is. And notice the little dots in her face that are actually made with red, but since they're spaced out, they look more pink, okay, because of adding the extra white space in between. So he primarily uses red, yellow, and blue in this specific painting that he created. And if you're familiar with those colors at all, you might think, hey, Sour, those are the primary colors. I'd be like, okay. It's like, I'm not sure if I agree with you because primary colors, you're supposed to be able to mix all other colors with them. And I don't know if you've ever tried to make like a magenta kind of color with these colors or try to make a decent green or purple. It's actually really hard, and we'll try that sometime. The actual primary colors are cyan, magenta, and yellow. Yellow is still a primary color, so you got one right. Okay. So this is very different from what we've probably previously learned. Okay. And the reason why I want you guys to know about these is because we're going to be working with these colors, and you're going to find that it's going to be really hard to mix paints, mix colored pencils, mix pastels properly unless you use these actual primary colors. So, you can tell that these are the primary colors because even if you look at a print or ink cartridge, it says it's a tricolor. You take a look at it, and it's made with cyan, magenta, and yellow. So even the printers that we use to print our color copies of things know what the primary colors are. If they were using red, blue, and yellow, we wouldn't be able to get the right colors mixed together for all our printing needs. So we can tell based off of here, that these primary colors, they work. So why don't we learn about these in elementary school? I don't know. Okay, that's not something that I know the answer to, but at least you're learning about it now, which is awesome. Okay, so we have actually two different sets of primary colors. Okay, we have what we call the additive colors, which is mixing lights. So these are the three colors of those cones that are in your eye that we saw in the video. Okay, you have a red cone, a green cone, and a blue cone. And when one of those doesn't function properly, that's when you have color blindness and that kind of stuff, which is a different conversation. We'll talk about it more later. And then we also have the subtractive, and that's when you're mixing pigments. So if I'm mixing paint, if I'm mixing watercolors, or if I'm mixing pastels, colored pencils even, this makes it these are the primary colors that you want to use to get the colors that you want. So these are considered subtractive colors. You don't have to remember that word, but I want you to know that when we mix pigment, we have our cyan, magenta, and yellow. And those, the red, green, and blue is what we get when we mix light. And notice how when you mix light, the overlapping colors are our regular primary colors are cyan, magenta, and yellow. And when you're mixing pigment, notice how it's green, red, and blue, and those mix together. Very interesting. What are secondary colors? So if primary colors are colors three colors that you can use to mix any other color, what are secondary colors? Well, we call them that because they are a color resulting from the mixing of two primary colors. Okay, so if I took magenta and yellow together, I would make a red. Okay, so that's how we're kind of thinking here. So taking two primaries to make a secondary. And this beautiful work by Mary Cassatt, she created this painting in 1890. A lot of her paintings dealt with the tender relationship between a mother and her children. So whether it's them just sitting on their lap, taking their daily bath, walking down the street, just this really tender relationship that they have. And this one, if we try to match it up with our original secondary colors, it kind of matches. We got some greens, we got some purples, kind of, and then we got some oranges. Maybe we're thinking about it in her dress, but in reality, okay, it matches really well with our actual secondary colors. So that's the red, the green, and the blue. So we got the reds and sort of like the light reds, and kind of that's what the pinks are in her dress. And we got sort of like a blue and green kind of thing going on in the background. So this is a really good matchup for our actual true secondary colors. Very cool. Do you like math? I actually really, really like math. I'm a art teacher that loves math, okay? Math makes sense, okay? So we're going to do some simple math, okay? You'll be fine. 1 plus 1. You got it. It's 2. See, I told you, it's painless. It's painless, okay? So here we have 1 is a primary color. Okay, primary means one. So if you're the primary person in the room, you're the number one person in a room. Okay, so primary. If we take a primary plus a primary, so 1 plus 1, we get 2. I hope you're thinking what I'm thinking. Secondary. If you take 2 primaries, so if you take 2 ones, put them together, you get a 2. So that's a secondary, okay? Notice how the first part of that word is second, which is, the number 2 person, okay? Beautiful. Okay, a little bit harder math. 1 plus 2. Boom. 3. Okay, so what if we take a primary color and then we add or mix together with a secondary color? Yeah, you probably don't know the answer to this one. I didn't tell you the answer yet, okay? It is actually what we call a tertiary color. So tertiary is 3. So we have a primary plus a secondary equaling a tertiary. So if I took yellow plus red, I would get orange. If I took magenta plus blue, I would get sort of this purpley color. Okay, if I took cyan and green, I get sort of like a teal kind of color, or like a, green cyan if you want to just, add a little hyphenated little mark right there. Works out just fine. So our tertiary colors are essentially the colors in between those primary and secondary colors on our color wheel, okay? So the ones in between, they're the in-between colors. Okay, so there's another category of colors that I want to talk to you guys. So we talked about our primary colors being cyan, magenta, and yellow. You can use them to mix anything. Then we talk about our secondary colors, which are 2 primaries that you mix together. And now we're going to talk about warm colors, okay? And when you think of warm, you probably think of like reds, orange, yellows, okay, or any combination of those. I think of, a hot sun. I think of the desert. I think of fire. Okay, I think of red chili peppers. Okay, so things that are hot or warm kind of come to mind, and they sort of fit in those color categories. And we have this beautiful painting by Frederick Church in 1862. He was one of those artists that would paint the beautiful landscapes that we have around us. And you can notice there's like a volcano in the background. There's this sunset, the big ominous smoke plume coming from the volcano, but this cascading waterfall. So this is just like an epic painting, okay? And using a lot of those warm colors to kind of give you an idea of the vibe, okay? It's like, yeah, it's super beautiful, but we also have this sort of like ominous kind of, got this eruption of a volcano in the background. It's kind of wild. So anyways, really cool painting. I love it. Fits in that range of the warm colors. Beautiful. And those cool colors are basically everything else that's left on that color wheel that we were kind of looking at. And those are the ones that contain blues and greens. You can throw purple in there maybe. And they appear on the opposite side of the color wheels, opposite side of the color wheel to the warm colors. So if we take a look at this watercolor painting by Winslow Homer in 1903, he uses a lot of cool colors. Now, you might say, Sour, there's totally red on there. Red's a warm color. Okay, remember I said color did a lot of things? It would define the edge of something. It would tell us where to look, grabbing attention, telling us the mood. So this whole blue thing is kind of like very calming. But he has these flecks of red in the sailor and in the flag, trying to give us an idea of where we should be looking in the painting. If the sailor on the boat and the flag were not so bright red, it'd be a little bit trickier to figure out where we're supposed to look. We'd look at the front of the boat off into the sea, and there's nothing there to look at. So the red is really helpful in understanding the composition of the painting and where we're actually supposed to look. Okay. So like I was saying, it fits really nice with that range of cool colors, those blues, greens, and purples. There's a couple other art terms that we're going to be talking about just a little bit. We got hue, which is a color. So color is what we see. Hue is the name we give to it. So if I am wearing a shirt that's yellow, okay, what I see, that's the color, and the name I give it, the hue, okay, is yellow. So the hue would be yellow for my shirt, okay? So kind of, tricky trying to, grasp how to use the word color in class, but color is what you see. It's that reflection of light. Hue is the name we give to things that we see in a specific wavelength. So if I see something that's yellow, the hue is yellow, okay? Then we have a couple other words. If we add gray to whatever hue that we have, that's called a tone. Adding white as a tint, adding black as a shade. And this is something that we talk a lot more about in my painting class, because we do a project in which we only use one color. So you have to create tints, tones, and shades to make it more interesting and make it look like something. The last thing I really want you to look at is actually this Color of Chemistry video by Art Rages with Nate. Fantastic information, actually just like really cool understanding how some colors are made. One of the colors that's my favorite, my ultimate favorite, is actually the black. There is a color black where it reflects no wavelength of like anything. So you could paint something this color and like I could paint, an object and set it on top of this, painted black surface and I won't be able to see it because it doesn't reflect any light. And it is just mind boggling. So check this out. Some really neat stuff here in this video. So that's all I have with the element of color. Stay tuned for more videos.